the three operations add, contains, and remove. Those are the definition of a dynamic set. So any data structure that offers those three is called the dynamic set. And then the data structure can offer optional operations like finding the largest element or similar, but those three are the three essential ones. But we realize from, I intentionally said that this is a dumb way to do this, asking what kind of elements does the collection contain. So here we could loop through the entire universe, and if the universe is infinitely large, so that's not gonna work out quite well. So we need a mechanism that when you have a collection that you can for each through the collection, same way as we can for each through the array. And the mechanism to do so, so if we look at these collections in general, is that Java doesn't have these generators and lazy sequences that we liked in Python. But in the Java standard library, there is a concept of an iterator. Iterator is the closest thing to the lazy sequence that we saw in Python. So iterator is something, so looking at the documentation, there is 4 methods. One is a default method, we don't need to care about that, we'll come back to these things in the last week. But the 2 essential methods, so this is again showing a nice philosophical difference between Java and Python. Python iterators essentially have just the next method, so anybody can tell the iterator, give me your next element, and the iterator either generates it, either computationally or by accessing the back data structure. And then if there is no more element, then the Python next for the iterator throws some kind of exception, stop iteration, if I remember correctly. But the spirit of Java, as we'll discuss in a couple of weeks, that exceptions are for exceptional situations, and reaching the end of the sequence is not supposed to be exceptional. So in Java, in the philosophy of look before you leap, this well-known expression for the Java, Python is more of the spirit that easier to ask for forgiveness than permission. So in Java, so what you're supposed to do is ask the iterator, do you have a next element to give me? So iterator, every iterator has this method, has next, and then if it does have a next element, then you're allowed to ask next. So the next is gonna throw an exception if there is no, let's look at the document, yeah, no such element exception called in Java, but this is not the Java style to use exceptions as a control structure. And then the iterator, when it's proceeding linearly through the sequence, also may allow, so this is optional, because if you have an iterator to some computationally generated lazy sequence, so remove cannot possibly exist, but the iterator that is backed by some collection then may allow elements to be removed. But this is now highly restricted, that you can only remove the element that was previously returned by next. So you have to call next first, and then remove automatically applies to the element that was just received. And remove then illegal state exception. So this what is this illegal state? So when an object offers some methods to the outside world, so then you can never turn off those methods. So the methods are there and anybody can call them at any time. But the illegal state means that the object is not ready to entertain, so to speak, not ready to receive visitors. So the object is in a state that some operation like the remove here is currently impossible. So then such a method is supposed to throw illegal state exception to indicate that not right now, we're not it's not the time to do this operation. So the Java iterator, it's the lazy sequence that generates the elements on command. So those elements can come from an underlying collection. So every Java collection class in the collection framework has a method iterator. Notice it is not called getIterator because get something would be accessing an attribute, and iterator is not an attribute. And then also to the same collection, these iterator objects are separate from the collection. They are nested classes from the collection so that they have access to the internals of the collection. They know how the data is organized internally, but the whole point of the iterator is to hide what is the underlying data structure, that you iterate through an array list and a hash set and any collection with the exact same for loop. So let's scroll down in the example collections demo. So here is an illustration of a polymorphic method that receives some kind of iterator. The iterator hides where the data is coming from. Is this an iterator to an array list hash set? Is it a lazy iterator like we're gonna be writing in a few minutes? That part is hidden because we don't care, but what we do care so is the element type. So what kind of elements is the sequence containing? So an iterator that produces integers is not the same thing as an iterator that produces strings. But so if your method expects integers, so of course then you cannot give it an iterator of strings and vice versa. But this basic operation, so you can use the for each loop as a syntactic sugar for it. So you can for each through the collection, or you can, I think you can for each through the iterator. Any iterable, I think not just, so even more general. So this idea that while the iterator has more elements to give you, then you ask for the next element, so this gives you the next element, and then the iterator internally takes a step past the element, so that next time you call next step, then you're gonna get the next element from the sequence. So what you do with each element returned is up to you. So typically you store it to a local variable. So here we just one-liner added to the total, but whatever you wanna do with your current element, this is where you do it. And you get out of the loop once the iterator has no more elements to give you, and then we return the total. So here we have a polymorphic method that is like the sum function in Python, gives you the sum of the elements of any integer sequence. And what about the sets and other collections? Well, so collections themselves are not iterators. So iterator is a limited view into the collection, but an iterator itself is not a collection, and vice versa. But because Java method overloading, so this becomes pretty painless. We can, as a convenience, so overload the method that return, so given an arbitrary collection, so we ask the collection for an iterator into that collection, and then just pass the iterator to this version that expects an iterator. So now any collection, like I said, so you can ask for any number of iterators. They're all independent creatures. They don't need to proceed in lockstep. So each one can step through the sequence. So step through the collection independently. So if it's a lazy sequence, of course, then the iterators have to be separate. But suppose you have like an array list of 1 million elements, so you could have multiple iterators traversing through the collection. Although we should note that if you are iterating through a collection, and especially if you have multiple iterators simultaneously, generally it's a bad idea to modify the collection that is being iterated. The results are unpredictable. The results actually, the collection subtypes, they display a great variety here. So some subtypes don't care, so like the honey badger, so you can iterate, and every iterator can modify arbitrarily, especially the subtypes that are designed for concurrency and parallelism. Those can take anything. Some other collections, they can detect that they're being modified. So immediately the moment that you modify, you get a concurrent modification exception. And so there is so the documentation of each subtype should document how tolerant the collection is modification while it's being iterated. Now looking at the iterator decoration. So I will recall the decorators. We had an animal barnyard, and then we realized that we would like to have loud and mirrored versions of arbitrary animals. And then I said there that if you understand one decorator, you understand them all because they all have the exact same structure. So let's read through this decorator. It's a bit, so it's a bit long, but one screen full. I think we can handle that for the video. So this one is the stuttering, the duplicating, whatever you call it. So take an arbitrary iterator and then act as an iterator that consults the values from the underlying iterator. Remember, the decorator object always consults its client, and then this itself, the next method, gives out each element dub number of times. So you could have it stutter like each element repeated 3 times or 5 times or how many you want. So how is every decorator the same? Is that first of all, the decorator object standing in front of the existing object, acting as its public face and representative. So decorator makes no sense to exist on its own, only in front of an existing object. So that's what we give it as a constructor argument. And then of course other necessary data, so the duplication, how many times to duplicate each element, given as other one. Notice again how the decorator is always part of the same class hierarchy that it decorates. So duplicating iterator itself is an iterator, so you can give it to anything that expects an iterator, and then it will just silently consult the underlying iterator and produce the duplicated sequence. So the logic of the methods next and has next, looking at them. So how does this know if it has a next element? So, well, if the current element has been given out dub number of times, so then this one has a next element if and only if the underlying iterator has one. And otherwise, if we're in the middle of the duplication, so then we do have an element to give out, so the answer is true. So this again the decorator, consult the underlying object as needed and modify the answer. And then when the outside world asks for this iterator, give me your next element, so then if the current element hasn't been given out as many times as we want, so increment the count of how many times it's been given out and return the cached element. Otherwise, so ask the underlying iterator, what is your next element, take it to the safekeeping, to the data field, initialize. So now we give it out once, return the value. Notice one more thing, so when you are subclassing a generic class, so then here we maintain the genericity the same way. So iterator is a generic class for a data type to be decided later, and the duplicating iterator so is also for the same data type to be decided later.